Imagine stepping onto Mars, feeling the crunch of red dust beneath your boots, and, against every expectation, taking a deep breath of fresh, Earth-like air. No suit, no helmet, just you, Mars, and a clear blue sky. Sci-fi? Not quite. The blueprints to make Mars hospitable already exist, and today, we're exploring how humanity could pull off the greatest planetary makeover of all time. Why are we so obsessed with Mars? For decades, it's been the crown jewel of planetary science. Not only is it close enough to realistically reach, but it's also got usable day length, mineral resources, and, crucially, water ice. But there's one problem. Its air is 95% carbon dioxide, and there's barely any pressure to speak of. No human could ever survive outside without a spacesuit. Yet. So, how do you turn a planet with almost no atmosphere into a place where you could fly a kite, plant a garden, or just breathe? It's the world's biggest engineering challenge, transforming not just the air, but the climate, the soil, and even the sunshine. Enter terraforming, the science and engineering of planetary transformation. The idea? Boost the atmosphere, raise the temperature, and fill the air with the oxygen we need. Here's how the blueprints break down. Step 1. Warm the planet. Right now, Mars' average temperature hovers around -63 degrees Celsius. To melt frozen water and create a thicker atmosphere, scientists have proposed deploying giant orbital mirrors, redirecting sunlight onto the Martian surface. Think of it as a space sunglasses, but in reverse. Another idea is to use greenhouse gases more potent than coal, like perfluorocarbons, which could be manufactured on the planet. Pump enough of these into the atmosphere, and Mars would start to thaw. The polar ice caps, made up of both carbon dioxide and water, would turn to gas, thickening the air and starting a self-sustaining greenhousing process. But heat isn't enough. Next up, creating breathable air. Earth's oxygen didn't just appear. Cyanobacteria and plants made it over billions of years. Cutting-edge concepts involve spreading extremophile microbes, genetically engineered to survive mass harshness, across the planet. These microscopic terraformers would convert carbon dioxide into oxygen. Meanwhile, bioreactors could accelerate the process, pumping out over habitations and, over centuries, the open air. Realistically, getting oxygen to safe levels could take thousands of years, but engineered biology might dramatically speed things up. If we want to go old school, vast forests of engineered trees could eventually take root, turning red desert to green paradise. What's the point of all this if Mars loses its new atmosphere to space? Scientists suggest building a magnetic shield at Mars' L1 Lagrange point, a sort of a force field to protect the planet from the sun's solar wind. Without it, our precious air would simply drift away. So, is this science fiction? Yes, for now. But every technology we've mentioned is either on the drawing board or being prototyped in labs around the world. The first steps, like growing algae in Martian conditions, are already underway. But why go through all this trouble? Because the project isn't just about Mars. It's about proving we can reverse damage, that we can engineer solutions at unimaginable scale, and that, maybe, the future of humanity is not confined to Earth. So next time you look up at the red planet, imagine it blue and green. And remember, the blueprints are ready. The countdown is on.